Determine the left end and right end behavior and the horizontal asymptotes, if any, or slant asymptotes, if any, for f of x equals 1 plus 2x minus x squared divided by x plus 1. If the highest power in the numerator is less than or equal to the highest power in the denominator, f of x will have a horizontal asymptote. If the highest power in the numerator is greater than the highest power in the denominator, f of x will have left end and right end behaviors of positive infinity or negative infinity. If it is exactly one higher, this will happen through a slant asymptote. F of x equals 1 plus 2x minus x squared divided by x plus 1. The highest power in the numerator is x to the 2. The highest power in the denominator is x to the 1. The highest power in the numerator is greater than the highest power in the denominator, so this will have left end and right end behaviors of positive infinity or negative infinity. Since it is exactly one higher, 2 is one higher than 1, this will happen through a slant asymptote. F of x will have a slant asymptote. The slant asymptote is found by dividing the denominator, x plus 1, into the entire numerator. We will want to write the numerator in descending order, so negative x squared first, then the 2x, then the 1. We will want to determine what this term needs to be multiplied by to match this term. X multiplied by negative x makes negative x squared. The negative x is put up here, and each of these are multiplied by negative x, which will give a negative x squared minus x. It's put in parentheses. The entire thing is subtracted. Negative x squared minus a negative x squared, those will fully cancel because minus a negative is the same thing as plus. The 2x minus the negative x, which is a plus x, 2x plus x is a 3x. And the 1 comes down. We now need to determine what we need to multiply this by to match this, which turns out to be a 3. So we put the plus 3 up here, and we need to multiply the x plus 1 completely by 3, which will give a 3x plus 3. It's put in parentheses and subtracted. 3x minus 3x will cancel each other out. 1 minus a positive 3. 1 minus 3 is a negative 2. X cannot be multiplied by anything to make a negative 2, and therefore the x plus 1 cannot further divide the negative 2, and it is the remainder, by writing the negative 2, still being divided by the x plus 1. It just can't further divide here. The slant asymptote is y equals the linear function without the remainder. Now to show that this is the case, f of x, which is 1 plus 2x minus x squared divided by x plus 1, can be rewritten after long division as negative x plus 3 minus 2 divided by x plus 1. The slant asymptote is determined by y equals the limit as x approaches positive or negative infinity of f of x, which is negative x plus 3 minus 2 over x plus 1. The remainder term will go to 0 as x approaches positive or negative infinity. The result is negative x plus 3, and f of x has a slant asymptote of y equals negative x plus 3.